And today, I'm going to change it up a bit. I'm actually going to be diving deep into category theory and lazy functors in Swift. I'm kidding. I don't know what any of those words mean. But I now realize you guys probably would have liked that talk more. So what we're really going to talk about is from sketch to Xcode. So we're going to build, similar to how Stephen did, a functional reactive view model, but we're going to do it kind of from the ground up. I'm going to kind of walk through like the thought process of how I create the inputs and the outputs, yada, yada, yada. So you're probably still asking yourself, who is this guy, and why did he make this slide so difficult to read? So I was born and raised in New York, as Brandon said, big fan of pugs. I was currently doing iOS work at Twitter and Uber the past like 7, 8 years. I'm currently the iOS lead at HQ Trivia. I'm also a former solid, object-oriented man turned functional once I laid my eyes on Stephen and Brandon. And I just haven't looked back. So most view model implementations focus on inputs and outputs in some form, whether it means they're wrapped in a struct or they're using a reference type. But the beauty of pure functional ones is that they take the principle of inputs and outputs to a huge extreme, where it's just nothing but inputs and outputs, as you saw with Stephen's example. And I think there's a lot of benefits to that. So let's talk about some of those benefits. So the biggest benefits I see is that it really isolates your logic from your side effects, which is great because it really helps you. It's the beauty of using a pure function is that it's very clear when you're trying to do something that is a side effect and it kind of just isn't working in this style. So it makes it more clear when something needs to be returned and run as a side effect versus something that is just pure business logic. As you saw before, it's very, very declarative, easy to read, and I personally think fun to extend. And I think some people here would agree. It's almost like you're more describing a recipe of taking inputs and then kind of just massaging them into outputs. So the constraints make it very clear when something is incorrect, which I think is my favorite part. Before I used to use view models, even with a functional reactive library, again, I'd use protocols. I'd have an input protocol and output protocol that was just another basket of other protocols. And it felt like there were so many ways of achieving that, of using different types of subjects, behavior subject, publish subject. Was I doing it right? Where do I hook them up in view did load, in init? Do I pass the view model in? So many questions. And what's beautiful about this style of just using a pure function is that it removes all these questions and it makes it a lot more clear when you're, the compiler will tell you when you're doing something illegal, which is really helpful because I hate thinking. And another big benefit is that it's very, very, very easy to unit test, almost too easy. I can explain kind of like how we do that, but I think it's fairly clear once you see. And it takes practice. Like I said, I've been working with Brandon and Stephen for about 6 months. Barely used RX or any functional reactive library before then, and now it's kind of second nature to me. And I know that there's like this learning curve, and it kind of like you bang your head on the table for like a month or two while trying it. But once it clicks, and I promise you, it'll click. If it clicked for me, it'll click for anyone. It's really wonderful. So let's get down to the nitty gritty. That's an HQ joke. So what we're going to do, let me just get some water. We're going to build an app to help us find the closest city bike dock. This is like a little kind of side project I've been doing on the side to kind of strengthen my functional reactive kind of skills. And the beauty is that I had previously worked on this on an app similar. It took me probably days or weeks to kind of get up and running. And using this new pure functional style, I was able to accomplish like all of this within like a day, including all the scaffolding, everything I needed. So this is what we're kind of going to try to build. Our PM, who doesn't really exist, gives us this mock, and he says, build this for me. So you can see we kind of have like, it just has a title dock finder. It's going to show us the name of the nearest dock, how far away it is. It's going to tell us how many docks are at that station. There's going to be a reload button and then a little label that kind of tells us the last time how fresh that data is. And then there's going to be a map. And our PM only had pictures of Cupertino because he had a really bad sketch template. But we're going to actually make it show the real map of where that station is. So when I look at something like this, which is often the workflow I have where I'm given kind of a mock or some sort of basic design, I need to think of how I'm going to transform it into code. There's certain steps I kind of go through of like, how do I define what is an input and how do I define what is an output on this mock? So classic example, UI controls, anything buttons, switches, sliders. These are classic examples of inputs. user interacts, kind of feeds into the system. But there's also less kind of common ones that are less obvious, like lifecycle methods on view controllers. If you did load, view will appear. App went into the background, foreground. These are still inputs. They're less, I guess, explicit and obvious because the user's not tapping or touching something, but it is certainly something that, like, an input that we'll use, again, to massage our data, turn it into an output. So these inputs can be very explicit and pure, which is, as you've seen, like a button was tapped, a slider was moved. But they could also be impure, which is kind of like how Stephen was talking about with networking, where we kind of pull them from a dependency graph and make a network request or grab core location. But they're always triggered by an explicit kind of input. And we'll talk about that in a sec. And then outputs. Outputs, the classic example here. Anything that's dynamic content that would change based on an input. So here, obviously, most of these labels, the name of the station, the number of docks, the last time it was updated, the map where it should pan to, those are clear kind of outputs in this example. And another good thing to remember is we want to make our outputs as close to what the view model needs. We don't want to kind of leak any domain-specific knowledge about our models. We shouldn't be returning any sort of like data structure. It should be strings, colors, or, like Stephen said, descriptions of side effects you want to perform. Cool, so before we jump in, just some disclaimers. I've been using RX Swift, but really any functional reactive library will work. I guess Stephen used Reactive Swift, and that's cool too. For RX newcomers, the really only thing you can kind of just let it just have an assumption is that an observable of a value is effectively just a stream of those values firing 0 or n times, like, over time. So you can imagine, rather than just having like an integer, it's effectively a stream of 0 to many integers that can fire at any time. And then there's certain details here that I'll kind of gloss over, like sharing observables and using dispose bags. Just ignore those, like everyone else says in their functional reactive talks. Cool, so some prerequisites to the code we're going to use. Is that visible? A yes, a head nod? Anything? Bueller? All right, I'll just talk through it. So basically, these are like 3 structs that I'm going to use in my implementation, but just so you're familiar with when you see it. So if any of you have followed Brennan Stevens' work on Point Free, this should be a little clear to you or known already. So we're going to have one struct that basically represents our API, and it's going to have kind of a property for every request you might make. And these are just simple vars, and the reason for that, I can explain another time, but basically so you can easily swap them in unit tests or for other reasons. So here, we just have one method that is, that this gets us our closest stations given a CL location. So we give it a location, and it returns an observable of an array of all the stations that are near you. That's it. Then we have our location manager. That's another struct, just has a simple property called location, and that is a stream of locations as you move around. And then finally, to tie it all together, we have this environment, something Stephen was talking about. This is nothing but like kind of a global struct that exists that you can pull these different kind of helpers off it. So this is where we access our API. This is where we access our location manager. This is where we get kind of helper functions like date that lets us pull it off the graph and call it to get the current date. And it's wonderful when you're writing tests, so you can kind of control and time travel, yada, yada, yada. Cool, so let's do a live demo against all better judgment. So just clap regardless of what happens. Thank you. I meant after, but that was really nice. So I want to mirror, hold on. Cool. Oh, this thing is really not comfortable on the wrists. Hold on. Cool, so is this, let's go bigger. Can everyone see this? Bigger? You got it. How about now? That's as big as I'm going. That work for everyone? Words? Yes. Okay, got it. Cool. So, so let's just remember what we were building. So this is what we're building. And I've kind of, again, built us a little scaffolding of the inputs and the outputs. We kind of described them all already, but here they're kind of pre-built, and they're stubbed out with these nevers. Similar to what Stephen said, this lets the code kind of compile without actually doing anything yet. So here you can see, I like you guys, I'm gonna go one bigger. So here you can see this is our view model. Very similar to Stephen's, pure function. Our inputs, as we described, were the reload button tapped. Let's look at what this looks like. So here you can see we have an input for when the reload button is tapped. We have again, more less explicit input view did load, so we're going to tell it when the view loads. And then the outputs, we're going to need the label text for the station name. We're going to need the text for the distance. We're going to need the text for how many docks are available. We'll need to know a location that we should pan our map to. And then finally, some label text for that little label that tells us the last time this was updated. So if we run this, so right now, like Stephen showed, we're returning a tuple of these outputs. And right now, they just do absolutely nothing. But this should at least let us compile. And then we're going to slowly start building this up from the ground up. Beautiful. OK, so this is our app. You can see it kind of doesn't have doesn't have great defaults. Kind of just like the labels are missing, but the button is there, the map is there to, I guess it's just zoomed out to the United States. So let's build it up slowly. So the first thing I like to do is just give it like some sane default values. Not too much logic, just like let's just get something on the screen, right? So let's start building these slowly. So the station name label. So let's start by creating that, and let's just give it some like constants. Let's just have this say locating, ... Very ominous. Let's take the distance label, and let's start that off with question marks. Ooh, very nice. OK, let's go with the dock count text. And again, we can give this just the old dash treatment. And then for the location of the map, let's just give it New York City, which is a little constant I added to see a location. And then finally, our label text, let's just make that say last updated never. Cool. So let's run this. Oh, let's actually plug them in. All right, so now we can actually start getting rid of our nevers. Now things start to make sense. Right, we're still not quite sure how we're going to actually fill these out yet. We're going to get there, but this is kind of the thought process I have. Like, let's just get the plumbing, the basic plumbing working. Let's get it compiling. Hold on. Oh, there we go. Cool. So now it compiles. That makes me happy. And then it's going to run. Cool. OK, so our basic kind of default data is plumbed through. Looks pretty good. Nothing actually happens. But now we're feeling good. So now we can go to the next step of like, let's start taking our inputs and transforming them, massaging them, merging them into these eventual outputs, right? So let's start with like, what do we need to get anything working, right? We need our current location, and we need these like nearby stations. Those are like the two basic things. Without those, we're kind of screwed. So let's start with the current location. We need that. That's pretty important. And the way I like to think about it is I like to kind of hook into an input that kind of kicks off the whole process. Usually it's view did load, but I guess it could be view did appear. It depends on what you're doing. But I kind of like it as like a little trigger input that kind of starts the flow of all of our observables. So let's take view did load, and let's flat map latest. See, I know how to flat map too. And we're just going to go into current, which is like our graph in the sky. We're going to grab the location manager and the current location. Right? So this is just going to be a observable if we look at the type. So this is just an observable of oh, it's very small. So that's just going to be an observable of locations. That's all it is. It's going to be very useful for more things that we do later. And now let's grab the nearest stations based off that location, right? That's pretty important. We need that to start filling out all of this. So let's say we have a property call or a variable called nearby stations, and that's going to be, let's say we'll also trigger that off view did load, right? So when the view loads, let's actually flat map again to grab those current location, that current location. That's going to be important. And then we can flat map again, double flat map extra points. So now we can go into our API, and we can call that one method called closest stations with a location, and we'll just pass it the location from the previous flat map. And now this, if what I did was correct, this should just be an observable of stations now, right? So we turned our current location into stations. So it's like view did load, flow in the current location, flow into stations. You're following me, cool. And I'm just going to share that. You can ignore that if you don't know what it is. Cool, so now we have our nearby stations. Still not quite at an output yet, but we're building up our intermediate kind of streams. So now the station name, right? So that we can do. So let's grab the closest station. This is ordered in closest to farthest, right? So let's grab our nearby stations. Hold on. And sorry. So the closest station is just our nearby station, and we're going to map over that, or actually, we'll map over that, and we'll grab the first one. All right, but since that's optional because first returns an optional, let's just filter map, so that'll get rid of like nils. And now closest station is just an observable of the closest station, right? So again, we're like flowing, we're building up our data, we're massaging it. That's a word I like to use. Maybe it's creepy, maybe I should stop. Cool, so we have our closest station, and now we kind of have exactly what we need to kind of start displaying all this data, right? So let's start building up these observables that before just had like our default data. So the name of the station, right? So before it was that kind of initial thing that goes on screen, but let's kind of merge it so that it initially gives us that locating thing, but then eventually, when we have our closest station, let's just map over that and return the name of that station, right? So now station name label text is at first locating, and then becomes the closest station once that's ready. Cool. And now let's go with the other one. So the other one is the distance label, right? Actually, I'll do that in a minute because that's a little more difficult. So let's go with like the number of docs available, right? So let's again go, let's merge both our initial value that we had. I really like that one. And then we'll merge that again with the closest station. And we will get that station's doc count, doc available. And we'll just say it's that number of docs. Cool. And then what else should we do? Okay, and then the centered location, right? So this shows us the location of that doc. And that's, again, a combination of our initial value. That kind of doesn't make too much sense, but at least it's better than zooming out the whole world. And this will be the closest station, and we're going to just grab that station's location. Cool. So we're almost fully plumbed up. Let's just do this distance. There's a little bit more logic here. So again, how far away is that station? This is effectively, let's say it's a combination of question marks with, here's where it gets a little interesting. So in order to figure out how far we are from this station, we need the station. We also need our location. And if you remember from before, we already have that here. So let's use that stream again, right? So we're going to get the closest station, and we're going to combine it with the latest from our current location. So now this gives us both the station and our location. And now we can kind of transform that a bit. So let's grab, hold on. All right, so this will have the station and the location. And now what we can do is grab the station's location, distance from our location, and that gives us, I believe, a distance in meters. But this is a tech talk, and I don't want to format that. So let's just make it an int of meters, and we'll just say that the distance is that many meters away. Cool. Still compiling. God, I hope so. Nice. OK, so we plumbed up all those so far. We have our initial values, then we have our eventual values. And let's do the final one. So this is interesting. So this is going to be the text that shows us the last time we fetched fresh information. So we can have that never, but then let's also merge that. I hope you're seeing a trend here. So let's see. So at closest station, that effectively fires every time we have a new closest station. So let's just kind of piggyback on that. Let's grab every time there's a new closest station, let's map over that. We don't really care what the station is. But let's reach into current, again, our environment in the sky, and grab the date. And I actually have a little formatter here. So this will look nice. String from date. Cool. So this should give us the date, like when this fires, when we get a closest station, we grab the current date at that moment, and that is how we know the last time was updated. And again, we'll format that nicely so our PM doesn't yell at us. Cool. So this looks pretty good. We plumbed everything in. We start with our view did load. We flow down. We grab our closest station, and we fill out all this information. And let's give ourselves, let's simulate our location. We're in New York. Let's run this and pray. You guys have been quiet for a while. Everyone all right? From before with the clapping. Okay. Cool. So here we go. So it's not the prettiest, but here you go. So now you can see it's actually fetching the current location. It's plumbing all that information through. It's massaging. It's merging with our initial values. And how you can see here that the closest station is Broadway ... That's, I'm not going to give a talk on compression resistance, but so this is the name of our station, Broadway and something. It's 163 meters away. There are 28 docks there, and this updated at 11:42, right? So pretty cool, and it centered it on New York, although a little zoomed out. So I think this really describes the power of thinking in outputs in terms of what you have to work with, which are your inputs. And the beauty of this is there's no intermediate state, no mutable variables. Everything kind of flowed top to bottom and eventually just was returned out as an output. And I've been using this system at HQ and for side apps, and it is, I would say, brilliant, but it's really fun and interesting because, again, you're kind of forced to think of how you can make your outputs from your inputs, and it kind of constrains you in a really nice way. And I thought as like a one more thing, let's hook up this refresh button, and I'll show you how easy it is to kind of add new inputs and turn them into outputs, right? So this does nothing right now. It kind of only updates on view did load, right? But you're probably thinking, adding a button and then doing another network request, that sounds like a lot of work, Danny. But it's not going to be. So let me show you how simple that is, right? So before, like what kicked off our whole process was view did load. That was like our hook. But now we want to also refresh our stations when the button is tapped. So let's kind of like redefine when we're fetching these stations, right? So initially it was just view did load. Well, let's kind of abstract that into like a more clear kind of idea of what we're doing. So rather than just view did load, let's call it like refresh stations, or let's just call it fetch stations, right? So when do we want to fetch our stations? We want to fetch them not just on view did load, but we also want to fetch them when we tap that button. So now this is nothing but an observable of just voids, which is like something happened, right? And that's when we want to fetch. We want to fetch on view did load and reload. And now if we just change that, I think this will work. Let's see what happens. Hold on, I think I have to set the location to New York. Cool, okay, so that's still there. And when I hit refresh, oh, you can see the last updated, obviously the same number of docks. If someone wants to run downstairs to Broadway ... and grab one, I promise you this will work. But here you can see, so now I'm refreshing and it's updating. And what's beautiful about this is that it's so easy to kind of like compose these observables from other observables. For example, if we wanted to add a 5-second timer that refreshes every 5 seconds, that would just be creating a new signal that just fires every 10 seconds, and I would just merge that in with its existing fetch stations. And you can do this, you can say when you come from the foreground, you should fetch stations again, right? It's all super easy and really easy to do, and it's unbelievably declarative, kind of flows top to bottom. I think this whole thing is 50 lines of code. So yes, I hope you enjoyed that. I'm not going to force you, but you could clap again. Thank you. And now let me see, will this work? I guess we can just do this like this. So, Okay, so just quick breakdown. This is like the thought process I use, and I think you just all watched it in real time with me sweating. So this is how I do it. So before you code, I like to just kind of figure out your inputs and outputs, like literally stare at your mock, and in your mind, just get used to saying, like, that's an input, that's an output. Stub out your outputs to get things compiling with those never signals. Build out your default values like we did, and then start building out your dynamic outputs based on your inputs. So that's the kind of, and I've been doing this for all sorts. Like if people maybe think, oh, it's only for like simple one-screen view models or views. I've done this with all sorts of crazy hierarchies, nested view controllers, real-time trivia games. So I'm pretty confident that this works in all sorts of contexts. So if you want to learn more, Steven has a wonderful talk called How to Control the World, where he goes over basically that like kind of environment that you can easily mock things out and test things with. We use that for getting our API requests and our location. You can also watch literally all of the things at Point Free. I'm not being paid to say this. All their videos are really wonderful, and they cover like most of these topics in depth. Or you can just kind of bug me on Twitter, and I'll answer you within like 3 weeks. And that's really it, so thank you. Good question. I immediately regret putting that line in now. What? So the question was, I gave a talk a few years ago about solid principles, about a lot of design patterns and object-oriented programming. I was a really big fan of that style of programming. I still use it frequently when I need to live in environments like UIKit or anything that is just inherently object-oriented. But I still prefer this more functional style. And it's not that I'm necessarily against solid principles, although I think, similar to how Stephen was describing, a lot of the kind of mindsets we have thinking in object-oriented land is, I think a lot of it is like solutions looking for problems. And if there's one thing I've learned from those two gentlemen that I work with often now, it's that like oftentimes things are just functions like hiding underneath a rug or something. So I don't think there's any single solid principle that's wrong. I just think, for example, that whole crusty talk that everyone loves, like we're kind of like, Apple kind of dictates and tells us these certain patterns to use, and now protocols, like let's make everything a protocol. I think they have a place in your toolbox, but I think often, starting off the simplest form of just like how would I make a pure function out of this is a really good starting point, and you realize like, oh, it's like this pattern to this. It's like, oh, hey, or I could just like write a function that goes from one thing to another. So I frequently found that I was over-architecting things, and now it's funny looking back at my old view models, which were very much in the style of like having a protocol where you define your inputs that were like taps and just functions, and your outputs were like closures or signals. And I look back now, and unit testing those things was such a pain in the ass. Having to make mocks and stubs of all these things, like having a mock network requester, and then putting that in, and then like building up these huge fake object graphs, which works, and that's why, I mean, I enjoyed it at one point. But then you see that you can kind of use these more kind of coarse, simpler, functional kind of patterns, and all that just kind of goes away. I mean, like literally, Stephen just like mostly deleted code for that talk, which I think is a beautiful example. So I encourage you, like, try patterns like this, and you'll kind of, and just have an open mind, because again, I had such a strong opinion about object-oriented programming and design patterns and protocolizing everything and thinking about what pattern works in which context. And then as I just started like asking myself like, why am I doing this? Like, how about I just make a function? It just kind of really like a lot of it started falling apart. So I still use those patterns when I need to, when I'm like stuck in object-oriented land, but I try to keep things as pure and functional whenever I can. That was a very long answer. Thank you. Anything else? Yeah, so I missed the last part, but I think I understand your question. And yeah, so the question was, do all of your inputs need to be reactive? Do they all have to be streams or observables of data? And The question is, they don't really have to. For example, let's say I wanted to have like an initial location that was like the starting point for this map, and I wanted to pass that into the view model. So I mean, I have that value. It's just like a CL location. I could have just passed that in as a just like as a CL location, not an observable of CL locations, and that would have worked. And then I would have just incorporated it into my streams and just done like an observable just of that constant, and that would have been fine. But where I find that doing everything in streams of observables is unit testing, because then you get to like really, you get to build up your view model, kind of have like a bunch of inputs, have your outputs, and then you kind of just like start tweaking and playing with your inputs and seeing what happens to your outputs. And when everything is an input, it lets you easily play with every single input in a function. Whereas if you have like one constant and then like 3 constants and 6 of your inputs are observables and 6 of them are constants, you lose that flexibility to really play with them all at once and kind of see where it goes. So I would say you can, but I think for testability, I found that going straight observable all the way really makes it flexible.
So can you clarify that a bit more? Like, I'm talking about a situation that under a time constraint, you say have to interact with something that's imperative. Say, I know we have Hertz Bluetooth, but say you have to interact with, the Bluetooth controller, which is not Hertz. In that situation, you hold your ground and say, we're not going to introduce this because it's imperative, and wait till you lift that up into a package for use it, or are there paradigms in which you can actually mix the two? I'm talking a lot about situations where you work in a greenfield code base, where you don't start with current API, pie in the sky that's already wrapped.
Totally. So the question was, do you have to go like full functional reactive view model all the time, or what happens if you're time constrained and you have a code base that is not reactive at all? And it's a great example. I mean, the HQ code base initially was not reactive whatsoever. It is now probably 90% reactive after a number of months of working on it. And so like it's actually, what's nice is you can build this up piecemeal. And the first place that we started was actually creating that environment and just starting, like, put simple things in at first, like just put the date. The date is in the environment graph, and then start putting network requests in there. And then, like, again, you have time, put your Bluetooth code, like, make that kind of reactive, put a little functional wrapper around it, put that in the graph, and you kind of piecemeal put it in there. And then eventually, everything is like reactive, but initially, there's ways of effectively, you can treat a lot of your outputs as like calls to make more imperative and side effecty kind of work. So if you need to, for example, like turn on Bluetooth, if you don't have a signal that is like turn on Bluetooth that you can kind of pass in as input, you can kind of have an output on your view model that kind of just describes that, like, you want to turn on Bluetooth, and then have a side effect in your view controller that turns on Bluetooth. So you can kind of like, you can start by putting like your side effects and your non-functional kind of more imperative code in your view controller, but still kind of control it in a functional way by outputting descriptions of what sort of imperative work you want done. So that's how I found it. And eventually, again, like now you have time, you have like a few hours of work, like take your core location, wrap it functionally, put it in the graph, and now start like deleting those outputs, and now you start using them as kind of hidden inputs. So this can totally be done piecemeal. That's how we did it. And I think it's pretty fun. Cool. Thank you so much.